Okay, so let's go through this checkpoint 17 of the circular motion. In an amusement ride at the entertainment park, a passenger sits in a cage which moves in a vertical circle at a constant speed, meaning that since the speed right is constant, so I know that centripetal force is equal to mv squared over r, means that the centripetal force is also constant throughout the ride. So throughout the ride, right, the passenger remains in constant with the floor of the cage. So of course, when the cage is as shown, at the position shown, right, what is the direction of the force exerted by the cage on the passenger? So just think of one thing is that the direction of the force, they never say it's contact force or what. So means that we need to take into account frictional force and the normal contact force together. Okay, so let's see this person. Okay, so at this particular orientation, right, imagine that this Ferris wheel is rotating at the clockwise direction. So what are all the forces acting on him? So first thing first, there's a normal contact force, and this normal contact force is actually providing the centripetal force. Okay, there's also a weight component. So of course, the person has a weight, right, mg. But since the person is not sliding down, because if you are at this particular orientation, if there's no frictional force, you actually slide down. So there must be a frictional force acting opposite to the weight component. So this force right here and this force right here must be the same in terms of magnitude wise. Okay, so since they say that what is the direction of force exerted by the cage? So meaning that I'm only interested in the frictional force and the normal contact force. So I just ignore the weight first. Okay, so at this point, right, we can say that the resultant force of the normal contact force and the frictional force will be in this direction. So this is the resultant force. Okay, so that is where we need to choose x. Okay, so what about if let's just say my Ferris wheel, right, is rotating in the other direction? Will the situation actually change? Okay, so if my Ferris wheel is rotating in the anti-clockwise direction, so same thing, let me just erase all this. Okay, so first there's a normal contact force also. So this is the thing that provides centripetal force. Okay, the weight is still acting downward. So in order to prevent the person from sliding down, right, there must be a frictional force acting upward right here. So this is the frictional force. So you can see that actually, be it in the clockwise direction or anti-clockwise direction, right, the direction of the forces will still be the same. So if you look at the normal contact force and the frictional force, the resultant force on the person, right, caused by the floor of the cage is actually in this direction. So the answer for checkpoint 17 should be D. So X regardless the direction of the rotation of the ride.